I like his screensaver.
Because I want to be able to recognize what he says.
You are so sensitive.
I know. All right. So I'm here to present to you guys BioView, which is a wearable sensor array for rehabilitation biofeedback. My name is Tyler Maydew. Here's my information. My team members Brett Donnermeyer and Katie Thompson will be introduced later. So the wearables market is rapidly growing. It's growing at an approximately 25% compound annual growth rate currently. In 2013, it was valued to be $4 billion, and it's expected to grow by 2020 to $11.6 billion. The reason the market is growing so rapidly is because wearables have really very recently exploded on the scene. A lot of you have seen the watches, the Fitbits, all these technologies that people don't really know how to completely integrate into their lives yet, but they're rapidly becoming a huge part of people's lives. The current market breakdown we're looking at capturing is a third of the market is focused on inertial measurement unit sensors and biopotential sensors. Our device takes into account both of these varieties of sensors, and it is approximately a third of the market. Currently there's some competition out there. We have Lumobac, who has a posture monitoring device, but it's just a little device on your chest that'll tell you and vibrate at you if it's detected you bending in what it's deemed an inappropriate manner. Another option is this biofeedback trainer that you'll strap onto your body, and it'll again vibrate when it's decided that you have a poor posture. Our device is meant to focus not on necessarily telling you that vibrating continuously to say your posture is poor, but to actually give you some real information on how to fix the posture. And we're currently looking at researchers and clinicians to interpret the data for you as our initial prototype. So that's really what's missing in this market. You have the Fitbits and the watches and things, nothing's going beyond your wrist. We can tell you the heart rate, we can tell you how many steps you've taken, we can tell you the calories, but nothing's going further into combining and actually monitoring what is happening in your muscles and what's happening as you bend or as you're actually going on. And our device takes the inertial measurement unit sensing, which is going to give you a position and angle of your spine, and it's going to take the muscle feedback. So if you're doing a weird action and you feel like your muscle's going wrong, you know what direction your spine was when that muscle was triggered. So you'll know exactly why you hurt and how you did it. So our solution is our product BioView. It's a wearable sensor, right? So that's really a shirt that we'll put on and that has detachable electronic components with 2 electromyography sensors at the trapezius muscle and the erector spinae, with batteries to the side and then a microcontroller at the base of your neck. And it all is focused on the circuit board. The device altogether weighs less than 20 ounces, so you will not feel over encumbered. My suit jacket is a lot heavier than that. So the team right now, you got me over here, I'm the electrical engineer, I'm designing the device interfacing, and then you have Katie Thompson and Brett Donnermeyer, who are really focusing on implementing the shirt onto the body and actually knowing more about the biomechanical aspects of this project. We're a whole bunch of engineers, so we're really looking for, at this time, as we build our proof of concept, our sales and marketing people who can really help us advance this product into the further realm. So thus far, we have created a proof of concept prototype, and we're working on testing it in a state-of-the-art laboratory at DU. We have a gold standard motion capturing system. And so we'll be able to check that our device is giving data similar to that gold standard motion capturing system. The Vicon system that we have here at the university costs $500,000. Our device to manufacture it at this point has only cost $350. And we're looking to move it on further to lower that cost. And so our next steps are really to get some actual users testing it and to optimize our design altogether. So the pipeline that we see our product going in, so right now we're focused on providing rehabilitation data specifically to clinicians. So we're not looking at telling you how to fix your body at this juncture in time. But moving forward, we can actually look at using this device to critically analyze the data that it gets and help communicate with that person, be it through an app or something similar to that. And then even further on down the line, you can see something like this being used as an everyday health monitor. This is a device that you can just put on when you're doing a sport or different work-related activity where posture is pivotal to not getting injured or properly performing that course. Our exit plan is the team anticipates that current wearable companies such as Fitbit or Garmin would be interested in expanding their product line, again, moving away from the wrist into something more over-encompassing. So, any questions?
There's a lot of steps, obviously, in front of you, and you've contemplated some of them. I would almost think that someone in the medical device or in the medical field would be your target exit, as opposed to Fitbit or Garmin or one of the others, because their model is different.
I say that what we're really looking at, our product currently is focused on that clinician behavior, but it's really an open source product for us, and it's more of a proof of concept than anything else. And so we see the medical device field as definitely an option, but we like the idea of the everyday health monitor field because it's much easier to enter. You don't have to go through the whole FDA approval process, and we just anticipate a lot of the areas in the health market are changing, especially right now with the Affordable Care Act, and so we don't think that it's a market we necessarily want to jump into, whereas you see the wearable market is something that's exploding onto the scene, and everyone's got to have their wearable piece of technology.
I don't understand the use case. You talked clinician at one point. You talk wearables like I'm looking this for my. I'm going to go get it myself. I don't get it. How do I end up wearing this thing?
So that's the key. That's our product pipeline. You're not meant to be wearing this right now. It is really still in the proof of concept phase. So right now, this is really designed to.
I know it's proof of concept, but I mean the use case. How do you end up with a customer in this?
So for example, I row, and so that's a sport that when you're rowing, you need to have exact posture to properly perform the stroke. And so a device that is giving you data on how to improve that posture is huge. And so you look at a company that is focused. There's some companies out there that are focused on making like shirts that correct posture. That this could augment. One of the company examples is AlignMed, and they make posture fixing shirts basically that help like professional athletes such as baseball players throw more correctly. And so something like this can even further augment that data. Whereas if you're just say you're a dock worker and you're lifting up something, if you don't do it correctly, you can seriously injure yourself. And so this is a device that can help you prevent that injury.
So I hurt my back already.
And so if you hurt your back already,
yeah, I played. I'm going to hurt it this weekend when I play rugby with this guy back there.
So if you've already hurt your back and you're looking at being rehabilitated, that's where this really goes into the clinician setting, where the clinician can look at this data and to examine exactly how you hurt your back. So like the combination of sensors will give you the muscle data and the spine position at the same time. So you can identify the point in time where you tweak the back and what motion you are actually doing at that time.
Okay, thank you very much.
Cool.
Thank you very much.